Today we have exponent rules. I did say 2.5, but 2.5 comes after exponent rules. So today, just these notes are just refreshing you on the rules of exponents that you hopefully know. And if you don't, well, you'll know them after this lesson. Okay, so if a factor is being multiplied by itself several times, we use exponential notation. Let B and N be any real numbers. This means that for exponential notation, B is the base, N is the exponent, and N is the number, the amount of times that we expand B times B times B, as you see in the examples below. So 4 cubed means 4 times 4 times 4, 2 to the 5th, 2 times 2 times 2 times 2 times 2, and ABC to the third means ABC times ABC times ABC. So the exponent, the power, or the degree, they all mean the same thing, tells you how many times you should write the number out and multiply it. Okay, so we have some properties of exponents. The first property says that b to the first power will equal b. So b to the first, any number to the first power will be itself. So examples of that are 4 to the 1 is 4, negative 3 to the 1 is negative 3, and n times t to the 1 is n times t. Property 2, very important rule here. It's the zero exponent rule. Property 2 says that any number raised to the 0th power will be 1. Any number raised to the 0th power will be 1. 4 to the 0th is 1, negative 3 to the 0th is 1, and 6xy to the 0th is also 1. Okay. 3, the negative exponent rule, b to the negative n, says that if you have a base or any number raised to a negative exponent, then you can rewrite it as a fraction 1 over b to the n. I would mainly worry about this final form, 1 over b to the n. So b to the negative n is 1 over b to the n. Examples of that, 2 to the negative 1 becomes 1/2. Negative 5 to the negative 6 becomes 1 over negative 5 to the 6. And PR to the negative 3 becomes 1 over PR cubed. Okay, so these are 3 important exponential properties. And of course, we'll practice them down below. All right, so get started here. Number 1, 5 to the first. Any base raised to the first power is itself. So 5 to the first will be 5. 2, 4x raised to the 0th power. So any number raised to the 0th, any base raised to the 0th power will always be 1. 3, 6xy to the negative 1. Here's where we're going to use the negative exponent rule. And if we rewrite it, we get 1 over 6xy. Okay. 4, we have multiple terms now. 5t to the 0th minus 4 times t, 2 to the negative 1 plus 2 cubed. So remember orders of operations. It's always, what is it? PEMDAS, parentheses, and then exponents. So here we do have parentheses, but there's nothing to work inside the parentheses. So we're going to go ahead and go straight to the exponents. So we'll take care of this term, and this term first. So 5t to the 0th will become 1 minus 4 times 2 to the negative 1 becomes 1 over 2 plus 2 cubed. 2 cubed means 2 times 2 times 2, which is going to be 8. Okay. And now still order of operations, parentheses, exponents, multiplication, division. So what we're going to handle next is this -4 times 1/2. -4 times 1/2. So you're going to have -1 and half of 4. -4 times 1/2 is going to give me -2 plus 8. Okay. And then we will work the last part from left to right. 1 minus 2 is -1. And then -1 plus 8 gives me 7. There we go. All right. Any questions on those 1 through 4?
No, sir.
Okay. Let's try it again. 5 through 9. All right. So 1 to the 6th. Well, that means 1 times 1 times 1 times 1 times 1. I don't know if I said that 6 times, but you get it. So 1 to the 6th is still going to be 1. And then minus, you have -1 raised to the 0th power. Remember, any number raised to the 0th power will be 1. So this becomes 1 minus 1, which will give us 0. Okay. 6. -2 to the 4th. Okay. So for these type of exponential expressions, we have to be careful. We have to take note that the base here is just 2. 2 is our base. And the exponent is telling us to expand this 4 times, which means we need to multiply 2 4 times. And all that negative is going to do is wait out front. So we're going to have negative out front, and then we're going to take that 2 and write it 4 times. 2 times 2 times 2 times 2. And 2 times 2 is 4. 4 times 2 is 8. 8 times 2, we get -16. Okay, so be careful with these ones. Because next, you have -2 in parentheses. So if there's parentheses around your base, this means that -2 in the parentheses is my actual base. And again, we're going to expand it 4 times. So this means you'll have -2 times -2 times -2 times -2. Well, just like above, 2 times 2 times 2 times 2 is 16. Here you get negative, which makes positive. I can even simplify this more. -2 times -2 will give you +4. -2 times -2 will give you +4. And here we get +16. So take note of the difference between the bases. Parentheses and no parentheses, you get a different answer. All right. Again, more practice here. -2 cubed. 2 is just my base. So this means when we expand it, you'll get that negative up front, and 2 times 2 times 2. We'll get 2 times 2 times 2, which is going to be -8. All right. And then -2 in parentheses cubed. That's the base. And this becomes -2 times -2 times -2. Simplify it. -2 times -2 gives me 4. 4 times -2 gives me -8. All right. So we get the same answer, even though the bases are different. So just be careful with the notations. All right. Any questions on that page? All right. Okay. More exponential properties. Yeehaw. Okay. First up is the product rule. So this says if you have x to the m times x to the n, so if you have the same base multiplying each other, then what you're going to do is add your exponents. You'll add your exponents. Same base multiplying each other, you add your base. You add your exponents. So b times b times b, the power on all these b's is a 1, which means b times b times b would be b to the 1 plus 1 plus 1 plus 1, which would give you b to the 4th. Another example, x cubed times x to the 5th. Since these are the same base, you would just add your exponents and you would get x to the 8th. Next one, abc to the 7th times abc to the 18th. Since these bases are the same, you will add your exponents and you'll get abc to the 25th. And then a to the 5th times a to the -2. Once again, same base, add your exponents. 5 plus -2, which is 5 minus 2, becomes a cubed. Okay, so product rule. Same base multiplying, add your exponents. Okay. Then the next rule is the quotient rule. Same base dividing each other, you will now subtract your exponents. X to the m over x to the n gives me x to the m minus n. So again, example, 2 to the 6th over 2 squared, same base, you subtract your exponents, 6 minus 2, this gives you 2 to the 4th. Again, x cubed over x to the 5th. You subtract your exponents, 3 minus 5, that gives you x to the -2, which you can rewrite by the negative exponent rule as 1 over x squared. So you can see how all these properties work together. Third one, sc to the 8th over sc squared. These have the same base, so you subtract your exponents. Sc to the 8 minus 2 gives you sc to the 6. All right. Which means let's go ahead and try out product rule and quotient rule below. What do we have? Just that page? Okay, cool. All right, first up, 4 to the 5th over 4 to the 4th. These, move down a bit. These are the same base. So this means you'll get 4 to the 5th minus 4. So you subtract the exponents, and this gives us 4 to the 1st, or just 4. Okay. 11. 2 to the 6th times 2 to the -4. Same base, multiplying each other, we will add the exponents. So you're going to get 2 to the 6 plus -4. which just becomes 6 minus 4, which gives me 2 squared, which will give me 4. All right. 12. Xy to the 5th times xy to the 9th. Same base multiplying each other. You will add your exponents. So you're going to get xy to the 5 plus 9, which will give me xy to the 14th. Okay. Cool. Any questions on those three? Okay. 13. Do it again. 6 squared over 6 to the 0th. Let me zoom in. There we go. Same base, which means you get 6 to the 2 minus 0, which gives me 6 squared. And 6 squared becomes 36. Right? 14. X times 4x to the 10 times 3x to the 5th. Okay. So what we're going to do first is handle the coefficients. So we're going to put this 4 and that 3 together. So we're going to have 4 times 3, which gives me 12. The next thing we're going to have is the x's together. So I'm just going to write them out separately. 12 times x to the 10th times x to the 5th. That's everything we have there. And now notice that all of these have the same base. This x is to the power of 1, so we product rule this. So x times x times x, we will add the exponents. So you'll get 12 times x to the 1 plus 10 plus 5, and we'll get 12x to the 16th. There we go. All right. $15. Definitely some work to do here. X to the 12th over x to the 12th y cubed over x to the 5th y to the 9th. So what we're going to do here is handle the variables separately. So we're going to look at x to the 12th, x to the 12th over x to the 5th. Same base over each other. We're going to subtract the exponents. So this is going to give me x to the 12 minus 5 times, and then we'll look at the y's. Y cubed over y to the 9th. Again, same base over each other. We will subtract the exponents. Okay. Simplify, and we get x to the 7th times y to the negative 6. Now I can rewrite this one more time because I can rewrite y to the negative 6. It has a negative exponent. So that means I can rewrite this as x to the 7th over y to the 6. There we go. That's how you handle product rule and quotient rule. Any questions on that page? Okay. More rules. Whew, so many rules. All right. First up is product to a power. So if there's a product of two or more factors within a parentheses and they're raised to an exponent, then you can raise them separately to that exponent. So we have x to the y, x times y to the m, which we can rewrite as x to the m times y to the m. So examples of that, 2x to the fourth can be rewritten as 2 to the fourth times x to the fourth. And if you simplified it, you'd get 16x to the fourth. So you can take those terms and raise them separately to that power. Okay, next is 5xy squared, which if you raise each term to the second power, you'd have 5 squared, x squared, y squared. And then xy to the fourth, you're going to get x to the fourth, y to the fourth. And of course, if you simplify, you'll get 25x to the 6th, y to the 6th. So that's product to a power, which means that next is quotient to a power. So if you have a quotient, a fraction raised to a power, you have x over y to the m, which becomes x to the m over y to the m. So first example, 2 over x to the fourth becomes 2 to the fourth over x to the fourth, which becomes 16 over x to the fourth. So we raise again each thing to the power. Next, 5xy squared, that would be 5 squared, x squared, y squared, xy to the fourth, x to the fourth, y to the fourth. And then you get 25 over x squared, y squared after simplifying. Okay. So that's product to a power. That is quotient to a power. Let's go ahead and try it out. So 16, a times b times c to the fourth. So a times b times c is a product, which means that we are going to raise all of these separately to the fourth power. So you'll get a to the fourth times b to the fourth times c to the fourth. All right, nothing to simplify there. And then 17, you have a quotient raised to a power. So 4 over 5 cubed becomes 4 cubed over 5 cubed, which you can expand into 4 times 4 times 4 over 5 times 5 times 5. And 4 times 4 is 16. 16 times 4 gives me 64. And then 5 times 5 times 5. 5 times 5 is 25. 25 times 5, I get 125. Okay. 18, 6x raised to the second. So this is product to a power. So again, I can rewrite this as 6 squared times x squared. And 6 squared is 36, and x squared remains the same. Okay. 19. D over 2 to the 5th. Here you'll get d to the 5th over 2 to the 5th. Well, if you don't know what 2 to the 5th is, then you can write it out, right? This would be d to the 5th over 2 times 2 times 2 times 2 times 2. D to the 5th would remain the same. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 2, we get 32. All right. Any questions on those four? Just refreshing everyone's memory. Seen these before?
Yes, sir.
Good.
It's about time something was in this class that I already knew.
Good. Well, again, more rules. Oof. All right. Power to a power. X to the m. So I have x to the m raised to the n. So a power raised to a power, you will multiply your exponents. So for x cubed raised to the 4th, you will just take 3 and multiply it by 4 and get to x to the 12th. This, of course, shows everything that's going on, but that's too much work. Just multiply the exponents, which I guess it made it easier down here. X to the 3rd raised to the 4th gives you x times x to the 3 times 4, which is x to the 12th. That's a lot easier. Okay. And then x squared y to the 5th raised to the 3rd. Well, you'll just raise each one separately to the 3rd power, which means you'll multiply those powers by 3. So you get x times x to the 2 times 3, y to the 5 times 3, and you'll get x to the 6, y to the 15th. So power to a power raised to a power, multiply your exponents. And hopefully the last rule, I doubt it though. Sign change rule. X to the negative m over y to the negative n. All you will do is flip them over each other, and you'll get y to the positive n over x to the m. So this uses the negative exponent rule. Okay, so keeping it simple, just flip them over each other and change the sign on the exponent. So x to the negative 4, 3 to the negative 2. Oops. You flip the x to the negative 4 down. That gives you x to the 4th. And you flip the 3 to the negative 2 up. That gives you 3 to the 2nd. Simplify, and you get 9 over x to the 4th. Okay. And then negative 2 to the negative 3 and 5 to the negative 2. So again, just flip them over each other. The negative 2 to the negative 3 becomes negative 2 to the positive 3 in the denominator. The 5 to the negative 2 becomes 5 to the positive 2 in the numerator. Simplify, and you get 25 over negative 8 or negative 25 over 8. All right. Sign change rule. So let's try it out. Okay. So 20. 3x to the 4th raised to the 2nd. So first thing we're going to do is the product to power rule. So this will become 3 squared times x to the 4th squared. So we're raising everything to the 2nd power. Okay. Well, 3 squared becomes 9. And x to the fourth raised to the second, that's power to a power. So you'll multiply your exponents. So you'll get x to the 4 times 2, which gives me 9x to the 8th. Okay. (21). Same thing. 5x to the negative 8 raised to the third. We're going to raise everything separately to the third power. 5 to the third times x to the negative 8 raised to the third. 5 cubed, we learned from the above, was 125. And x to the negative 8 to the third, that's power to a power. So you will multiply your exponents. And you'll get 125 x to the negative 24th. And then by the negative exponent rule, we can rewrite this as a fraction. We can rewrite this as 125 over x to the 24th. There we go. All right, 22. This is going to use the sign change rule. So 22, we just flip them over each other. So that x to the negative fourth, I'll put a fraction symbol here. Come on, pen. There we go. So that x to the negative fourth flips to the denominator and becomes x to the positive 4. That 7 to the negative 2 flips to the numerator, and you'll get 7 squared. Simplify. 7 squared is 7 times 7, which is 49 over x to the fourth. Okay. And now 23. A times b to the negative 3 over b to the negative 1. Sign change rule first. And we're going to get b to the first power over a times b to the positive 3. So we sign change rule and we flip them over each other. Okay, but we can simplify more because in the denominator, we can now do product to power. So you're going to get b over a cubed b cubed. And we can simplify the b's. So if we look at these, that's going to use quotient rule. So this is going to become b to the first minus 3 over a cubed. So remember quotient rule, we subtract the exponents. We'll get b to the negative 2 over a cubed, and then take that b to the negative 2, flip it to the denominator, and you get 1 over a cubed b squared. There it is. All right. Any questions on those 4? All right. Of course, more rules. Let's see. We're gonna get into rational exponents. So let me bring these out. Let's see. Let me see what we're working with. B to the m over n. Okay. So this first power, since it's probably hard to see, this next rule for exponents, rational exponents as that, if you get b to the m over n, well, there are multiple ways to rewrite this. So one, you can rewrite this as b to the 1 over n raised to the m, or you can rewrite this as the nth root of b raised to the m, which means that you can also write this as the nth root of b to the m. So many ways to rewrite this one. But I guess I would focus more on, let me see. You get the nth root of b over m. And then there, and then there. Okay, yes. So let's do this a little better. So there's not so many things you have to look at. So I'll put a star next to this. If you're ever given the nth root of b to the m, then you can rewrite this as the nth root of b to the m, which means that you can have one final rewrite as b to the m over n. So I would just focus on this one instead of all those confusing ones. Okay. And I guess I need an example of that. So if I had the cube root of, let's say, I'll put b in here, why not? I'll say b to the 5th. I can rewrite this as the cube root of b, all raised to the 5th, which means I can rewrite this as b to the 5 over 3. There we go. Okay, that's good enough. Get rid of all that crazy stuff. Okay, and then let's see. Do I need these ones? Yes. All right. Number 1, it says the nth root of x to the n is x. Well, if your root index is the same as the power or exponent inside the radical, then the result will always be x. So maybe you can see that here, but if not, we can do another one. Let's say I had the 4th root of x to the 4th. Since these powers are the same, the radical would cancel and we would be left with x. So whatever the power of the root is, and if the power of the exponent are the same, it will always cancel out to become x. Okay. The next property is going to be the nth root of x times y can be rewritten as the nth root of x times the nth root of y. So if you can see this one says the 5th root of x times y can be rewritten as the 5th root of x times the 5th root of y. I'll do another example. Let's say I had the cube root of mn. Then what this property says is I can break it up into multiplication. I can make this the cube root of m times the cube root of n. So all this property says is you can break up a radical by multiplication. Okay. And then the third property is the nth root of x over y. If you have a fraction inside, then you can make it the nth root of x over the nth root of y. So for their example, they have the 4th root of x over y. which can be rewritten as the 4th root of x over the 4th root of y. And I'll do another example. Let's say I had the square root of 2 over 3. Then I can just rewrite this as the square root of 2 over the square root of 3. So this property allows us to split up radicals by division. Okay. So now we're going to put, let's see, simplify each expression and write answers using positive exponents only. So simplify each expression. Oh yeah. So we're going to put together everything we've learned so far. All right. So number 1, x to the 1/4 times x to the 7/4. So now we're using all the properties we learned today. These bases are the same. So that means we're going to add these exponents. So that means you're going to get x to the 1/4 plus 7/4. Since these fractions have the same denominator, that gives you x to the 8/4. And 8 over 4 reduces to 2. That was nice. Okay, 2. Y to the 3/4 over y to the 9/4. These are the same base, so you will now subtract your exponents. So you'll have y to the 3/4 minus 9 over 4. Again, these fractions have the same denominator, so just subtract the numerators and you'll get y to the negative 6 over 4, which means 6 over 4 reduces to 3/2. So you'll get y to the negative 3/2, which by the negative exponent property, we can rewrite as 1 over y to the 3/2. It says simplify each expression and write answers using positive exponents only. Okay, so that means that one's done because 3/2 is now positive. Okay. 3. 9x to the 6, y to the negative 2, all raised to the 1/2. So now for this one, we're going to use the product to power. We're going to raise everything to the 1/2 separately. Bring it down. So this will become 9 squared times, not squared, 9 to the 1/2 x to the 6 to the 1/2 and y to the negative 2 to the 1/2. Okay, we have some work to do. We are going to leave 9 to the 1/2 alone for now. But now x to the 6 times 1/2 to raise to the 1/2 means power to a power. You'll multiply your exponents. So 6 times 1/2 or half of 6 gives me 3. Same thing over here. Y to the negative 2 raised to the 1/2, power to a power. You multiply your exponents. Negative 2 times 1/2 or half of 2 is negative 1. Okay. The next thing we're going to do is use the negative exponent rule. And I'm going to rewrite this as 9 to the 1/2 times x cubed over y. Only thing we have to worry about now is this 9 to the 1/2. So this is going to use the exponential property, the rational exponential property above. So 9 to the 1/2 is the same as x to the m over n, which means I can rewrite it as the nth root of x to the m. So this means that this is going to become the square root of 9 to the first. Ooh, just come on, pen. Stay with me. And the square root of 9 happens to be 3. So our answer over here just becomes 3x cubed over y. All right. Any questions on those three? It's a lot to look at, but we're using everything we've learned so far. Okay, these three. 4. X to the 2/3 times x to the negative 3/5. Again, same base. Add your exponents. X to the 2/3 times, it's going to be x to the 2/3 plus negative 3/5. Oh, this time we don't have the same denominator. So in order to add these exponents, we're going to need a common denominator. So that means that you have 2/3 minus 3/5. The common denominator between 3 and 5 is going to be 15. So that means you get 10 over 15 minus 9 over 15, which will give you 1 over 15. So our final answer here is x to the 1 over 15. Okay. 5. 9 to the 2/3 raised to the 6. This is power to a power, so the operation here is multiplication. So you're going to get 9 to the 2/3 times 6. 9 to the 2/3 times 6. So 2/3 times 6. Well, I can make that 6 over 1. That would give me 12 over 3. Because with fractions, you multiply straight across, which gives me 4. So this means you get 9 to the 4th. I don't think it told us to solve it, just simplify it. So we're going to leave that as 9 to the 4th. But if I were to type that in, that is 6,561. Okay. 6, x to the 4th times y to the negative 4th raised to the 5 halves. This is product to power. So we're going to raise each one separately to the 5 halves. So here we'll get x to the 4th raised to the 5 halves times y to the negative 4 raised to the 5 halves. And now you have power to a power on both of them. So you'll multiply the exponents. Okay. So 4 times 5 over 2. Well, 4 times 5 is 20. So you're going to get x to the 20 over 2 times, same thing here, Negative 4 times 5 over 2, you get y to the negative 20 over 2. Reduce those, and you'll get x to the 10th times y to the negative 10. Now, using the negative exponent rule, we can write our final answer as x to the 10th over y to the 10th. And ooh, that was fun. All right. Any questions on that page? Exponents get crazy. All right, last page. Change each expression to radical form. Do not simplify. Okay, so here's where we're going to be using that property again. So I'm going to write it above just to have it. If we have, I'll say x to the m over n, we can rewrite it as, and this wants to go straight to radical. So we're just going to go from this form to this form. Actually, since there's an 8 in there, let's see. No, I'll write the second step then. So you'll have the nth root of x to the m, and then this can become the, oh, wrong one. Nth root of x to the m, which can be written as the nth root of x to the m. There we go. So we're going to be using this property, which we'll start with 7 times y to the 2/5. So be careful about parentheses and no parentheses. The 7 is attached to the y by multiplication, but they are not together. So the y is the only term being raised to the 2/5. The 7 is not. So this is the only term we have to worry about converting to a radical. So going from exponent to radical. So that means this becomes 7, and now we have y to the 2/5. Well, y to the 2/5, using this property above, we're going straight to this third step. The denominator of the exponent becomes the power of the root, and the numerator of the exponent becomes the power inside the radical. So this will be 7 times the 5th root of y squared. That's it. This one says, do not simplify. Okay, so it just wants us to write it as a radical. Okay. 8. You have parentheses 8x to the 3/2. Well, again, this one's tricky. Yes, there are parentheses, but the only term being raised to the 3/2 is this x. So this becomes 8. And again, we're going to that final form, which that means you'll get the square root of x cubed. Now remember, the square root, you could put a 2 there, but that symbol has always been known as the square root. So we know there's a 2 in there, but we don't have to write it. So that's done. And now, number 9, you have 8x to the 3/2. Now, this one, because of the parentheses, 8x is now the base being raised to the 3/2. So we convert, and we're going straight to that final form. And you're going to get the square root of 8x cubed. There it is. It said, do not simplify. We're just rewriting it as a radical. Okay. 10. X to the negative 7 halves. So first thing we're going to use is the negative exponent rule. So this becomes 1 over x to the positive 7 halves. And now we're going to go from exponent to radical. So we're going to go to that final form again. And this is going to be 1 over the square root of x to the 7th. There it is. So that's going from rational exponent to radical. Just watch your parentheses. Okay. Next, change each of the expressions of the radical expressions to expressions involving exponents, fractional exponents. Okay, so now we're going backwards. So I'll write this rule over here. Now we're going from the nth root of x to the m, and we're finishing at x to the m over n. Okay, which means for 11, the cube root of x squared, well, if we're going to this final form, remember that the index of the root, index or the power of the root, will be the denominator. And then the power inside will be the numerator of your rational exponent. So this means that the cube root of x squared becomes x to the 2/3. Done. For 12, the 5th root of x cubed, same thing, is going to be x to the 3/5. And then 13, well, we have a little bit of work to do here. So 13, you'll get 1 over, and the cube root of x is going to be rewritten as x to the 1/3. But now we can use the negative exponent rule and rewrite this as x to the negative 1/3. And then last, the square root of x to the 9th. This will give me x to the 9 halves. There we go. So that was going from radical to rational exponent. All right. Last 3. Simplify. Determine the rational number representations for each. So this one wants us to actually reduce these numbers. So 16 to the 1/2. So if we use our properties from above, 16 to the 1/2 becomes the square root of 16. Again, there 2 goes in there and that 1 goes there, but we don't need those there. We know that that is the symbol for the square root. And we're going to get 4. 16. 16, 16. 16 to 3/2. So rewriting this, you are going to get the square root of 16 cubed. The square root of 16 cubed. Okay. Well, remember that we can also rewrite this as the square root of 16 cubed. And square root of 16 is 4. And 4 cubed is 64. All right. Last one. 17. 16 to the negative 3/2. Well, first off, we have to use the negative exponent rule to make this 1 over 16 to the 3 halves, which means that I can rewrite this as 1 over the square root of 16 cubed. Hey, this looks familiar. So we know our answer is going to be 64, but let's get there. Then this can be rewritten as the square root of 16 cubed, which will give us 1 over 4 cubed, which gives me 1 over 64. I need a new pin. There we go. And that's it. Any questions on that page? Seemed a little brutal, right? But other than that, we are done. That was exponents. That was your refresher.